I wanted to work through some examples for the one proportion z-test, and they are hypothesis tests, so we follow the same basic steps that we have previously learned, but our focus now is going to be on a proportion, specifically a population proportion, where previously our focus has been on a one mean, specifically a population mean test. And so I'll point out some ways you can tell the difference between these tests. So our first example says an organization published an article stating that in any 1 year period, approximately 10.5% of adults in a country suffer from depression or a depressive illness. Suppose that in a survey of 100 people in a certain town, 8 of them suffered from depression or a depressive illness. Conduct a hypothesis test to determine if the true proportion of people in the town suffering from depression or a depressive illness is lower than the percent in the general adult population in the country. Now, there are two clues that I see here that kind of give me an indication that this is going to be a one proportion test. First of all, if you get to the last sentence, it says conduct a hypothesis test to determine if the true proportion. So it actually uses the word proportion. Had it not done that, the other clue is that my information is given in terms of a percent or a percentage. So the first step in any hypothesis test after reading the scenario, which we just did, is to state the hypotheses. So we need to state our null hypothesis, and we need to state our alternative hypothesis. And we follow the same rules as we have in the past. The null hypothesis should contain equal in some form, and the alternative is the exact opposite. I know sometimes you guys struggle with identifying the hypothesis, but this one kind of helps you out here because it says in the last sentence, conduct a hypothesis test to determine. And then it gives you a statement. If the true proportion of people in the town suffering from a depressive illness is lower than the percent in the general population in the country. So the general adult population here would refer to, again, the population. So we're looking for our population parameter. And because we're dealing with a proportion instead of the symbol for mean, we use a lowercase p. It is not a Greek letter, it's just a basic p. So our population parameter that's going to be in our hypothesis is a p. If I go back to the first sentence, it says approximately 10.5% of adults. The other phrase that's important here is it does say is lower than. So I hope when you see that word or phrase is lower than, you think of the math symbol less than, which does not contain equal, which tells me this statement is the alternative. So if I translate that statement into symbols, I have the population proportion is less than the 10.5%, and I convert 10.5% to a decimal. Now, if you guys have forgotten how to do that, to convert any percentage to a decimal, you take the decimal value or the percentage, and divide by 100. So it becomes 0.105. So my statement in the scenario is the alternative. So P, the population proportion, is lower than or is less than 0.105. By default, then, the null, which is the exact opposite, is going to be greater than or equal to that same percentage. The second step that we have to do in a hypothesis test is what I call identify the players. I need to know what information I have been given, and then also so that I can have all my information organized to put into Minitab. And there are really 4 pieces of information that you need. You need P, you need X, you need N, and you need alpha. P is your population proportion, and it's the value that's in the hypothesis, which is 0.105. X is what we call the number of successes, meaning we get what we want. How many responded to our question in the affirmative? We got what we want. N is our sample size. How many did we actually include in our sample? And alpha, as always, is the level of significance. Now, all of this information should be given in the problem. So if I go back up here and I read, and I focus on that second sentence, it says, suppose that in a survey of 100 people in a certain town, 8 of them suffered from depression or a depressive illness. Okay, that's going to give me my information. Okay, we surveyed 100 people, so that is my sample size. That tells me how many people I questioned, and the question would have been, do you suffer from depression or depressive illness? And it tells us in that same sentence that 8 people from this particular town responded, yes, I suffer from depression or depressive illness. So my X, which is the number of successes, is 8. Now, one thing I notice in this problem is it doesn't give us the level of significance. The standard is, if you're not given the level of significance, by default we use 0.05. Again, that's just kind of the standard across the board. A lot of researchers will leave that level of significance open-ended so that as the reader, I can make a decision and come to a conclusion for myself based on whatever level of significance I would prefer to use. Okay, so I have all of my information. I've stated my hypotheses. I have collected all of my information from the problem. So now I'm ready to calculate the test statistic, and I do that in Minitab. So I'm going out to Minitab, and we go to Stat, Basic Statistics, and this is a 1 proportion test. 1 proportion. And I have the summarized data. Okay, the number of events is the term that Minitab uses for successes. We had 8 successes out of 100 trials. We are performing a hypothesis test, and it asks us for our hypothesized proportion, which comes from the hypothesis and is 0.105. Under options, we're using a 95% confidence, but I'm using a less than. My alternative hypothesis was less than, and I need to do a normal approximation. Click OK. And then I'm going to click OK again. And again, Minitab does the work and calculates the test for me. The Z value, okay, so from Minitab we get our results. Now let me see if I can get it to copy. Maybe I didn't copy it correctly. I want to copy. And then we're going to come over here and we're going to paste. Okay, so here are our results from Minitab. Okay, I find that my Z test statistic is negative 0.82 and the corresponding p-value is 0.207. So even though Minitab has given it to me, I have to record those onto my paper or answer the question that is given to me. Okay, then we have to make our decision. To make our decision, we compare the p-value, which we got from Minitab, to the level of significance, which we're using 0.05. So as I make this comparison, I do it digit for digit. So the first digit after the decimal place for the p-value is a 2, for the alpha is a 0. Well, 2 is greater than 0. Therefore, the p-value is greater than alpha. If the p-value is greater than alpha, the guidelines tell us to fail to reject the null. If I fail to reject the null, let me go back up here to our null and alternative hypothesis. If I fail to reject the null, that means the null is true and the alternative is false. Okay? So, what that tells us is that the true proportion of people of that town suffering from a depression or a depressive illness is not lower than. Okay, so I can basically take this statement, okay, that's here. Let me see if I can highlight it for us and copy it, because I can basically take this one statement and make it become my conclusion, because I would say at the 0.05 level of significance, you always include your level of significance in the conclusion, the true proportion of people in that town suffering from depression is not lower than the percent of the general population in the country. Now, there's other ways to say it, okay? But basically what we proved based on our evidence that we have is that our null hypothesis, which says the population proportion is greater than or equal to 0.105, is true based on the evidence we have. Now, there again, if I go to a different town or a different country, we might come up with different results. But based on the evidence we have at this particular moment, in this particular scenario, we have found that the population proportion is greater than or equal, aka not lower than 0.105. Okay, so let's take a look at a second problem. The second example says a poll done for an organization found that 13% of Americans have seen or sensed the presence of an angel. A researcher doubts that the percent is really that high. He, I guess I should say, or she, he conducts his own survey. And so out of 75 Americans that he surveyed, only 2 had seen or sensed the presence of an angel. As a result, is the researchers' survey, would you agree with the organization's poll? Conduct a hypothesis test at the 5% level. Okay, now this one is not maybe as straightforward as the previous problem, so you may have to, in some ways, if you want to call it reading between the lines, okay? But they tell us what the poll says, and then it says the researcher doubts the percent is really that high, okay? So this statement that I've highlighted in yellow is actually the hypothesis. Now, it you may think it doesn't seem that obvious, but again, ultimately they're asking you, would you agree with the organization's poll when the organization is saying 13%? Okay, but the researcher doesn't think it's really that high. So the researcher doubts the percent is high. So use some logic. If it's not really that high, he thinks it's less than the 13%. Okay, that's what the researcher believes. Now, again, you got to pay attention to the wording, guys. You got to use some kind of logic, common sense here. So he doubts that it's that high, which means he thinks it's less. So again, the first step in any hypothesis test is to state the null and the alternative. The null, again, has to contain equal in some form, and the alternative is the exact opposite. So again, the researcher thinks it's less than 13%. So the percentage is less than 13%. Again, write your 13% as a decimal. The opposite would be the percentage is greater than or equal to 13%. Remember, your null and your alternative are exact opposites, and the null will always and forever contain equal. Okay. The second step then is to identify the information that we're given in the problem. Again, you need your population proportion, you need your number of successes, your sample size, and your significance level. So I know that my population proportion is the 13%. And then I need to go back and I'm going to read, I believe it's about the fourth sentence, and it says, out of 75 Americans surveyed, only 2 had seen or sensed the presence of an angel. Okay, so that tells me that in this problem, there were 75 people surveyed, and 2 of them had seen an angel or sensed it. And then it tells us to conduct our hypothesis test at a 5% level. So I've collected all the information from the problem. I'm going out to Minitab. Again, we go Stat, Basic Statistics. It's a one-portion test. We're using summarized data. We had 2 people indicate they had seen or sensed the presence of an angel out of the 75 surveyed, and our proportion is 13%. Again, we're doing 95% confidence. We are actually doing less than again, and we're doing a normal approximation. So again, Minitab does all the work once I get the data input, and it gives us our results. Okay, so let me get them copied over here. Okay, so this says our Z test statistic, which I'm going to write down. You need to record your test statistics. So my Z test statistic is negative 2.66. My p-value is 0.004. I then have to compare that p-value to my level of significance. So I'm going to compare p to alpha. P 0.004, alpha is 0.05. Again, if I make that comparison and I do it digit for digit, in both cases the first digit is 0, the second digit for the p-value is 0, for the alpha it is 5. 0 is less than or equal to 5, so the p-value is less than or equal to alpha. When p is less than or equal to alpha, we reject the null. If we reject the null, that means the null is false and the alternative is true. So then the last step is to write our final conclusion. We would say at the 0.05 level of significance, the percent of people who have seen or sensed the presence of an angel is less than 13%. Now, I put a lot of details in there, guys, but the details are important. That gives your conclusion the context and relates it back to the original scenario. And again, we found, so the question really says, as a result of the researcher survey, would you agree with the organization's poll? The answer is no, because we've found that it's less than 13%, and they're saying it is 13%. Okay, so there's 2 examples of a one proportion Z test.